All right, I want to give you guys a little bit of a review for your quiz tomorrow. My third hour, one of my students said, "Want to know if I like the show? Everybody Loves Raymond." And I said, "Yeah, why?" And he says, "Because you sound like the older brother." And then I was told yesterday that I sounded like the State Farm guy. State Farm guy.
Can you say it, please?
So I don't know. All right. Why don't you guys give me some questions on last night's homework? Something you couldn't get to, maybe. Yeah, go ahead.
54.
All right. Let's read it.
What number?
54.
Right.
Cotangent of theta in terms of cosine. All right. Now, what I told you guys to do for every problem is to turn everything into what? Sines and cosines. So let's do that. So I know that cotangent is cosine theta over sine theta. I want to write this in terms of just cosine. So I've got to change that sine to cosine. So I look at the Pythagorean identity, the one that says sine squared theta plus cosine squared theta equals 1. And if I subtract, remember we have three forms of this, correct? So sine squared would equal 1 minus cosine squared. And so sine, then, would equal plus or minus the square root of 1 minus cosine squared theta. That's what sine is equal to. Plus or minus the square root of 1 minus cosine squared. Well, if that's what sine is equal to, then I can write further my identity as cosine of theta over, instead of sine, I'm going to write plus or minus the square root of 1 minus cosine squared. And now I've taken cotangent and I've converted it into, in terms of sine, or cosine, I'm sorry. Okay? And that's what you got to do. All right, what's another one? Would you like me to read the answers first?
Yeah.
To see how you did? All right. So we'll do that, and I'll pause the recording. All right. If there's no questions, let me tell you what's going to be on your test tomorrow. We've had 3 sections. Section 14.1. First of all, we dealt with the area of a triangle. Your review today does not have anything to do with area of a triangle, but it's going to be on your test. To find the area of a triangle, there's 3 forms. K is equal to, for instance, 1/2 AB sine C. That's given side angle side. We can find the area of a triangle given side angle side. Okay. We can solve that triangle using law of cosines, but so know that formula for area. Okay, and then there's 3 forms of that. K is equal to 1/2 BC sine A. K is equal to AC sine B, and so on. Then the law of sines. The sine of angle A over side A is equal to the sine of angle B over side B. which is equal to the sine of angle C over side C. Okay. When do you check to see if there's more than one triangle? Side angle. Are we okay with that? Or would you like to see an example?
Yeah.
Yeah. Given side angle. Maybe we're given angle A as being 30 degrees. Side C and side A. All right, and let me make sure, let me get the numbers right. And side C would be 2, and side A would be 1.5. Now look, in a triangle, there's your triangle. Doesn't have to be fancy. Here's A, B, C. Here is side C, angle A, side A. Given side angle. All right? So we have the sine of 30 degrees over 1.5, using law of sines, is equal to the sine of C, angle C, over 2, side C. Multiply both sides by 2. 2 times sine of 30 over 1.5 equals the sine of C. What is the sine of, what's the sine of 30 degrees? 1/2. 2 times 1/2 is 1. So I've got 1 over 1.5 equals sine of C. I was helping a student this morning going over the quiz that we just took. And we had a couple of problems there, and not bad. The person got a C on it. And I said, well, let's see where you made your mistakes. And the mistake was having calculator in radians when it should have been degrees, or being in degrees when it should have been radians. There were a lot of points taken off and should have been in the mid to high B range. So if you look at this problem that I've just done, should your calculator be in degrees or radians? Degrees. All right. So you want to check real quick to make sure that your calculator is in degrees. It is. All right. And then we want to hit second sine, because we want to find the inverse of 1 divided by 1.5. And we find that it's 41.8 degrees. So angle C could be 41.8 degrees. Is it possible to have another angle? Now here's what you have to do. Let's make a little drawing here. Here's 41.8 degrees. What quadrant do I have to check in? Quadrant 2. Quadrant 2, where the reference angle is 41.8. And I want to check this angle right there. And what is that angle? 138.2. So could angle C be 138.2? The answer is yes, it could. Look at the given angle. The given angle is 30. 30 plus 138 is 168. I've got room for another angle, don't I? That's how you can tell. angle B, if it were 41.8 degrees plus the 30 degrees, that's 71.8. So 108.2. So that third angle could be 108.2, or if this angle was 138.2 and 30, that's 168.2, then this would have to be 11.8 degrees. So you understand what we have here? We've got the three given side angle, and then we have the two there, angles written in black, or they could be the angles written in red. Then we have to find the missing side, which is side B. And how many different sides will we get? We'll get two. We'll get one using the information in black. For instance, sine of 30 over 1.5 is equal to sine of 108.2 degrees over side B. And we're going to find the side B for the black measurements here, 41 and 108. And then I'm going to do the problem again. Sine of 30 degrees over 1.5, the givens, equals, and now I'm going to go sine of 11.8, and that's for the red. And so I have two different sides for side B. Okay, does that make sense to you guys? Now, the question is, if you found that second angle, and the second angle is going to be bigger than the first one, because I'm in the second quadrant. If you find that the 138 and the one that's given is over 180, there's only one triangle, isn't there? Okay? All right. Then there's a possibility there's no triangles. What situation would you get there? I mean, how would you know if there's no triangles at all? Yeah, if the sine of an angle is greater than 1. I think on your review today you're going to have something where the sine of an angle is 2.37 or something. Yeah, well, there's no triangles. Yes.
Can you go over our side?
Yes. Well, this was section 1, right? Now, section 2 had to deal with triangles, and I don't know if this one's going to work because I'll just make it up. Do you have something in the book for side?
I have one from the front.
Yeah, just give me one.
A equals 11.3, B equals 7.2, C equals 14.8.
Given side, can we solve the triangle? Yes. But we have to use law of cosines. Okay, the law of cosines, here's one of them. A squared is equal to b squared plus c squared minus 2bc times cosine of a. You want me to go over that? All right. So side A is 11.3. Side B is 7. Whoops, sorry.
That's interchangeable, right?
7.2 squared plus 14.8 squared minus 2 times 7.2 times 14.8 cosine of A. I'm assuming by that question, interchangeable. There are different forms, you understand, using different letters. And if I wanted to find angle B first, that formula would look like b squared is equal to a squared plus c squared minus 2ac cosine of b. So it depends what angle you want to find. I chose to find angle A. In your calculator, we put these numbers in. You have that written down? 11.3 squared. Do you have those numbers?
Yeah.
That should be those.
127.
127.69 equals
270.88 minus 213.12.
Now, I took the square root of 7.2, which is like 50 point something, plus the square root of 14.8, which is about 220, and added those two together to get 270.88. Do not take the 270.88 and subtract 213. That's a tendency when you see all those numbers to start combining everything, but you can't. This cosine A is attached to the 213, so you're going to leave it there. So now I'm going to subtract 270.88 from each side. Alec.
Negative
0.9. 0.19. Okay. Equals negative 213.12 times cosine A. Notice I've got a negative on both sides. So cosine of A, dividing by negative 213.12 on both sides, cosine of A is equal to
0.671875.
is equal to that decimal. Cody, what would happen if we had cosine A equals 5.671875? There'd be no solution, right? But we're on our way here. I can have a triangle with those dimensions. You go to your calculator, second cosine, making sure your calculator's in degrees, second cosine 0.671875. We're looking for the inverse function. And you will get the angle measure for angle A, which in this case should be 47.A. That's from the notes we did. That's why you get the name in class. It's the notes. Okay. 47.8 degrees. Now, once we do that, then what? Then we use law of sines to find the other two angles. Okay? So, law of sines, law of cosines, area of triangles, and then your identities. And we spent 2 days on the identities, all day Friday, all day Monday. Bless you. All right? And that's your quiz. Your homework, as a review, is going to be on page 930, 931. Like I say, bless you again. I know how you feel. There is no review for the area of triangles, but know how to do that. And then there's only 17 problems. And what I'll do is, in just a second, I will put the answer key on the Elmo so that you have the answers to this review work. All right, we'll work on that for the rest of the class. All right, we want to write this in terms of cosine. All right. In terms cosine. Right away, as soon as you read that problem to me, I saw this 1 minus sine squared, and that's cosine squared. And that's from our Pythagorean identity. That's what that is. Okay? We had the sine squared plus cosine squared equals 1. So cosine squared is equal to 1 minus sine squared. Times. On all these identities, I've given you a strategy on where to start. Anybody remember what I said on where to start on these? Yeah, put everything in terms of sines and cosines. Then the rest just becomes easy. The rest is all your arithmetic skills, all your algebra skills. So I'm going to take 1, and I'm going to turn secant squared into 1 over cosine squared. Because that's what secant is, 1 over cosine. Now I'm going to use my algebra skills, and I'll distribute. Cosine squared times 1 is cosine squared theta. Cosine squared times 1 over cosine squared is 1. That's it. So I've taken the original problem and turned it right in terms of cosine. Okay. Is there anything else? You know, I'm looking at some work that I've been looking at for my students all day long. I see where there's much too much work being shown. And I say how much work should be shown, and you should show your work on everything, but I think it's a lot simpler if you follow certain strategies. And one of the strategies is change everything to sines and cosines. You know, there shouldn't be more than 2 or 3 steps on these problems. Okay, Luke, what'd you have?
38.
All right, what's 38?
Cotangent squared theta over cosecant squared theta equals cosine squared. Yeah.
Cosine squared?
Yeah.
And you want to show that one equals the other.
Yes.
Work one side. I don't think I want to take cosine squared and try to manipulate that and have that equal cotangent over cosecant. I don't want to do that. So I'm just going to work to one side. So I'm going to take cotangent squared. I'm going to rewrite divided by cosecant squared theta. I'm just going to write it like that. So I'm not going to have this compound fraction there, complex fraction. I don't want that. Cotangent now is cosine over sine. Cosecant is 1 over sine squared. You see where we're going? When you multiply, or when you divide fractions, you multiply by the reciprocal, flip and multiply. And one of the properties of multiplying fractions is I can cross reduce. Sine squared theta will cancel out. And I'm simply left with cosine squared theta. So cosine squared equals cosine squared. Okay. Yes.
Can you do number 12?
Yeah, I'm not a fan of those.
No, I can't get it.
The x's and y's, yeah. What does it say?
1 plus cotangent squared theta equals cosecant squared.
This is one of our Pythagorean identities. They want you to prove it. Okay? It's really, here's the information. We're going to need x's, y's, and r's. We need x's, y's, and r's, and I also know that this is true. I know that cotangent, I know tangent is y over x, opposite over adjacent, y over x. And cotangent then would be x over y squared. So let's square them. Cosecant, well, sine is y over r. Cosecant is r over y. And cosecant squared then would be r squared over y squared. And we know that to be true. That's by definition. So we really haven't shown that, we haven't proved anything. So we're going to look at the left side. And 1 I'm going to write as y squared over y squared, because that's 1. But I want to have a common denominator. Plus x squared over y squared. Now that I have the common denominator, I can add the numerators together. And what is y squared plus x squared? R squared. R squared over y squared. That's using the x's, the y's, and the r's.
Are we gonna do that?
No, like I said, I'm not a fan. I think it's more useful to use the identities that we've been using.
And I can test this on like the new 54.
Sure.
It's right in terms of cosine.
All right, and I want to write cotangent of theta in terms of cosine. Okay. Cotangent is equal to cosine. Did you get this far? And what is sine equal to? Well, John, go back to the other screen. And I guess it's this one here. No. Well, sine and so sine squared theta is equal to 1 minus cosine squared. Sine theta is equal to plus or minus the square root of 1 minus cosine squared. Correct? So if that's what sine is equal to, then I can write this as cosine of theta over plus or minus the square root of 1 minus cosine squared. That's all you can do. Now I've written cotangent in terms of cosine. Okay? Yes?
Do you have to rationalize that?
No, you don't. No, that's not what this is about. It'd be easy enough to do, but... All right, now, before we go any further, what I told my other students is that I want to, while I'm recording anyway, I want to put this on the website. I hope that's clear. Sometimes if I use that Elmo, things don't come across very clear. It's what? Yeah, but we're only going to do 1 through 17. So I think we can kind of make it out. I'll just leave that on there for a few seconds. But I don't know if you've gone to the website a lot. You guys can pause that, right?
Yeah.
Sometimes on the computer, when you pause it, it fuzzes up a little bit, doesn't it? No? Well, maybe it's just mine. All right. But I think that's... See, I don't know if that helps or not. But... All right. Well, I think that's long enough.